Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we are going to continue to learn about pandas. In previous video we looked in much detail about the wind type Gaussian. In this video we are going to look at the wind type exponential. And on this slide, which is similar to what we have seen in previous two videos, here we have the same setup where we have the values that we need to calculate the means for, and for that first we need to calculate the weights, and here we have the normalized weights that are calculated on the formula shown right here. Once we have these normalized weights, we can multiply these values. For example, 12 multiplied by the corresponding weight of 0.0674, and we can get the multiplication value, which is 0.809. And when we add all these values up, we get the sum, which is 14.99, and that is the rolling mean for this window of size 5 that goes where the values are 12, 22, 12, 11 and 32. Now to calculate the weight itself, how do we do that? So here I have a table which shows how the method is. So on the top right corner we have the formula, and here we are again going to use the window size of 5, which means that there are 5 data points that we need window created on, and the tau is set to 1 for this exponential window. We have points 0 through 4, we have median 2 for that, and so use that to center those points and then divide it by 1, which is the value of tau, get the absolute of that, that removes the negative sign, and then exponentiate each of those values and then add them all up. So these are the weights, and if you add them, the total is more than 1. Now if you divide each of these values by the weight that's below, for example divide 0.1353 by 2.00, then we get 0.0674, and if we do that for all the rows, then that column now has the normalized weights. If we go ahead and add those weights, the total would be equal to 1, and these are the same weights that we saw in the previous slide. So let's get started in Jupyter Notebook and create the window function for exponential. Then we'll go ahead and calculate manually the values for weights, normalized weights, and based on that we'll calculate mean, exponential rolling mean, and exponential rolling sum. And finally, as in the previous video, we'll create a nice visual animation to see how the window function walks through the entire data set to create the new values of average or means that can be plotted. So let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported these libraries: NumPy, Pandas, Matplotlib.pyplot, as well as 2 additional libraries. SciPy, from SciPy we are importing signal to create the window function for exponential, and from ipython.display we are importing clear output. So when we are going to animate the plots, this will help us clear the output of the previous plot in the for loop. We do not have any specific data because we'll go ahead and create it on the go. So first we'll create an exponential window, and for this we'll use the SciPy library. So window, again window, let's create a variable which will store the values. So window is equal to signal dot exponential, and here we need the value of m, so number of data points, let's say 51, and we need the value of tau, we'll set it to 1, and we can now go ahead and plot this. So plt.plot window, And why don't we go ahead and give it a title. So title is exponential window, and this has the tau value of 1. Next we'll give this x label, and x label is just a sample or data points, and plt.y label is amplitude. Now when we go ahead and plot this, so this is my mistake, ylabel, and when you plot this we should see a nice window function. So this is a nice exponential window that we have created. In the example that we are going to work on, we'll minimize this size from 51 to 20 so that we can see the animation very clearly. Now let's go ahead and work through the example, which is the manual calculation of exponential entities, because we are going to calculate everything. So first we'll set random.seed to 0 so that the data set remains the same, and this is the same data set that we used in the previous video for the Gaussian. So DataFrame, and here we have the same column y, and we'll set random dot normal, and here we can set the size to 20 as we had before. And now when we look at df, we can see that we have this nice data frame ready. So the next step is we'll set the value of variable x to df.index, and the reason is because we are going to use that as a x-axis while plotting. And for y, df.y, again this will be for plotting purposes where we plot raw values. Then window size we'll set it to 5, and tau value we'll set it to 1. Now next we'll go ahead and calculate the regular mean. So df y and dot rolling, and here we have window is equal to window and mean. So this is just the regular mean without any exponential terms in it. Next we go ahead and initialize the initialize arrays to store the values for moving average and moving sum. So for moving average we have y underscore smooth underscore mean is equal to np.zeros. The reason why I've put the smooth word there is because this is also called smoothing. So we have a very noisy plot. When we get the average moving average, we are actually reducing the noise and making the plot look much smoother. np.zeros, df.y.shape, and again we have this as 0. So once we have that, now we can go ahead and create the same loop that we had before for Gaussian. So for I in range, and here we are going to use the shape of the column y. So we have 20 values in there, and minus window plus 1. This is just to adjust the iterations. Now the first thing we are going to do here is get values in the window. So in each iteration there will be a specific window coming in. So for this we'll store this in the variable z. So df.y.iloc, and here we'll go from I to I plus window. So only those 5 rows will be selected. Now xvals variable will store the index of z. The reason is because we are going to calculate the weights based on this particular value of xvals. And next we are going to use yvals is equal to the value in the data frame. In this case we have already set the series to z, so it's just z here. After that we need to get the weights, and to get the weights, the function, if you remember from this slide, which is this one. That's what we are going to use. So let's call it xer for the raw values, and what we need to do is x underscore vals minus np dot median x underscore vals. So that's the first step. After that, this needs to be divided by tau, and then we are going to take absolute of that and then add minus to it, and then we're going to do exponential of that to get the final value of xer. And for xe, which is the normalized version, we'll divide the xer by sum of all the weights that are in xer. So let's go ahead and check this. So yep, that's what we are doing. So we have the absolute, and then we put a negative sign and take the exponential for that. Once we have the weights ready, it's time to multiply the values in column y with the weights and store them in the smooth arrays that we have initiated earlier. So y underscore smooth underscore mean is equal to, sorry, we also want to specify the index, so I plus window minus 1. The reason for this is earlier values will be nn in the original data frame, so when we join it to that, this will take care of that and will shift it down and align it correctly. Next is equal to np dot sum. We are going to sum the multiplication value, so y underscore vals into xe, just that, using normalized values. Okay, and then the next one is x underscore smooth underscore sum, and here again we are going to I plus window minus 1, and this is going to be equal to np dot sum. In this case, we are going to use y underscore vals into xer. So here we are using weights that are not normalized, using not normalized weights, and this should be weights. Okay, so those are the two differences there. Once we have these, now we are ready to create the plots. So let's create the plot. Clear underscore output, and here we have weight is equal to true. This line removes the output, so if we are plotting multiple plots on top of each other and we want to remove the previous plot from the previous loop, this will take care of that. Now plot dot bar x comma y, this is our raw data that we have, and I'll set the alpha to 0.25 again, and plt dot plot. Now this x underscore vals, this is where we are going to plot the weights. So this is normalized weights that we are going to plot right here, and color is equal to orange. So thus we should be able to see a nice animation of the window function, exponential window function, moving through the data. We set the pause to 0.5 and then plt dot show. Now when we run this, alpha is not defined because this should be okay. So here we can see that we now have an exponential window function that's moving through the entire data set and calculating the moving average and moving sum and storing it in these two variables right here. So let's go ahead and now plot the output. So the output would be the final plot, which will have all the data and the averages, as well as the data frame will do that. Clear underscore output, and again weight is equal to true. Now for figure, we are going to say figure is equal to plt dot figure, and here we set fixed size same as the previous video. We'll set it to 20, 5, and now plt.subplot. We have 1, 2, 1. We have plot number 1 there. Plt.bar. So this is the bar which will have the original data, which is set to alpha of 0.25, and then we have plt.bar. This is the new calculated smooth data, so smooth underscore mean, and here we will set the alpha is equal to say 0.5 and color is equal to orange. Okay, and then the second subplot adjacent to it will create again a line plot, so we'll use plt.plot instead of bar, and this again will have the raw data. So we'll set the alpha is equal to 0.25 and set the color to gray so it stays in the background, and label this as original data. Once we have that, you can then also plot plt.plot x, and this is now the regular average. So we have alpha is equal to 0.50, color is equal to, let's give it again blue color, and label is equal to, this is just mean, and then plt.plot. Finally we have our smooth mean, so y underscore smooth underscore mean, and then we won't use alpha for this. We'll use the orange color, orange, and label this as exponential underscore mean. Okay, so this should create the plots that we are looking for. And then finally plt.legend and plt.show. Before we okay, let's go ahead and look at the plots, and then we can go ahead and create the data frames right here. So as you can see in this nice animation, we see the exponential window that we created. It's moving through the entire data set through each window and creating this exponential moving average that we have. So there is an error subplot, I missed the B there, so we should now be able to see the second plot as well. So this animation, it's important to remember to use that command clear underscore output to get this to work. Now this is the exponential mean we have plotted in the orange, and again, as we saw before in the previous video, we do see reduction in noise where these extreme values -1 and above 2 are no longer there in the smooth curve that we have in the middle of the plot. Now moving on, now let's go ahead and create the data frame and add the columns that we have calculated. So we'll also calculate the same values of mean and sum using the rolling function, and win underscore type is equal to exponential. So df pandas underscore exponential mean, and here let's move this, and we are going to say y dot rolling window is equal to window, and then win underscore type is equal to, this is going to exponential, so exponential, and then dot mean, and here we need to specify tau. For Gaussian we have to specify the value of standard deviation, and for exponential we have to specify value of tau. So df and the calculated value, so for exponential mean we already have that and stored in the y underscore smooth underscore mean array. So we will go ahead and copy paste this. So the next we are going to calculate the sum. So all we need to change is replace the word sum by mean, and that should calculate, that should put the values of sum in the data frame. So when we run this, we should now see nice charts of the moving averages, moving the raw data, and then see the data frame with all the columns, which we can check if we calculate correctly. So here we have the values calculated by pandas dot rolling function using the win type is equal to exponential, and this is the mean value, this is the sum value, and they seem to match with the calculated values that we have from the code above. That's awesome. That's really encouraging. So this was what I wanted to show about exponential windowing and rolling, calculating the moving average and moving sum using an exponential window. I hope by this series of 3 videos you have learned the importance of rolling function and how to use different types of windows to work with the data to calculate moving averages and moving sums. I'm sure you'll encounter uses of these in several projects, especially in time series data sets. This would be really helpful. That's it for this video. I hope you learned a lot of new things. Please let me know in the comments below if you'd like to see any other functions discussed as well. Please like, share and subscribe. It helps me stay motivated to create more interesting content for you all. Thank you, and I hope to see you all in the next video.